Alright, now let's look at A dot B cross C, and when we solve this, we're going to use the matrices method instead of the distributive property. So first let's do B cross C. The first line will be your unit vectors, I, J, and K caret. And your next line across will be the first vector. And that's going to be Bx, By, Bz. And the third line will be the second vector, so Cx, Cy, Cz. And with the matrix method, the only thing you really have to do is take the first and second columns and copy them outside of the matrix, and we use that to kind of make the problem easier to solve. Bx, Cx, J caret, By, Cy. Okay? Now, with the matrix method, you go this way is positive, minus this way, and this will be Bycz minus Bzcy in the I caret direction, plus, and the J caret direction will be this way is positive and that way is negative. So we write Bzcx minus Bxcz plus, and the third way will be that way is positive, that way is negative, Bxcy minus Bycz, Cx, let me double check, Bxcy, Bycx, okay. K caret. And that's it. The distributive method takes a lot longer, but the matrices method is really a shortcut to solve this problem. And now what we can do is use the dot product. We're going to dot A with B cross C. And I'm going to write that here. A is going to be AXI plus AYJ plus AZK. And we're going to dot that with all the terms inside of the cross product. Bycz minus Bzcy in the I caret direction plus Bzcx minus Bxcz in the J caret direction plus Bxcy minus Bycx in the K caret direction. Alright, now I'm going to erase this to just kind of get that out of the way. And what I'm going to do is draw the I'm just going to draw the matrix for that, and I'll write I dot J, I dot K. This is going to be J dot I, J dot J, and J dot K. And this will be K dot I, K dot J, K dot K. Now, I dot I is equal to 1. I dot J is 0. I dot K is 0. J dot I is 0. J dot J is 1. J dot K is 0. K dot I is 0. K dot J is 0. K dot K is 1. And so you get the identity matrix. And when you use the dot product, you can simplify your either your matrix or your distributive property. And I'm just going to use the distributive property for this because the only thing you really need to do is dot I with I. Because I dot I is equal to 1, and you just have that term times this term. Now, I dot J is equal to 0. So when you dot I with J, that term becomes 0, and I dotted with a k becomes 0. So with the distributive method, this term is 0 and that term is 0, and this term stays. So I'm just going to use the distributive method for this because it's a lot shorter. We only end up with 3 terms. So we have ax bycz minus bzcy. I'm going to put I dot I plus ay, and the j term will be bzcx minus bxcz, and that's j dot j, plus az times the k term bxcy minus bycx, and that's k dot k. And the dot products will all equal 1, so they kind of go away. You multiply times 1. And the final step to take with this will be multiplying or distributing ax into here, ay into here, az into here, and then writing that all in one line. So we'll go ahead and do that now. Ax bycz minus ax bzcy plus ay bzcx minus ay bxcz plus az bxcy minus az bycx. And that's it.